we have just seen that CSMACD does incorporate two very intelligent mechanisms of carrier sensing to avoid any collision and collision detection as a mechanism to manage a collision that has taken place. We also saw that Aloha gave 18% and slotted Aloha gave 36% efficiency. We are interested in determining how much improvement we could observe if we are using CSMACD. For that, in this module, we shall first determine what are all the factors which affect the efficiency with relation to the operation of CSMACD. And then we'd look at the variants of CSMACD, each with its own respective performance. The references are Tannenbaum and Quiroz and Ross. Obviously, when we talk about efficiency, the first thing that comes to our mind is how long does it take for data to be sent from sending node to the receiving node, because longer the time interval, the likelihood of someone else sensing the channel idle and attempting to transmit increases. Similarly, the transmission time determines how much of the overall channel is utilized by the sending station. So, while the former, that is propagation delay, may be undesirable, the transmission delay or the transmission time is desirable. Another aspect is what is the behavior of the other nodes present in the network. If all the nodes are active all the time, it actually means that CSMACD is going to give up. It is going to break down because it's a probabilistic scheme which is based on the assumption that not everybody is active at the same time. If everybody is active at the same time and that is the behavior of the network, it means that some other deterministic kind of strategy should be used which pre-allocates resources to all the users which want to stay active. If it's a partially loaded system, that is, some nodes transmit with some probability using CSMACD, we expect the performance to improve. And of course, if the nodes are transmitting sporadically and their transmission durations are also short, it means it's a no load kind of situation. CSMACD is meant to help improve the efficiency, but the efficiency is only going to improve if there are transmissions. If there aren't any transmissions, CSMACD can't be of much help. Basing upon the previous discussion that we just had, efficiency can be seen to be composed of the ratio of the propagation delay and transmission delay, and of course these are in the denominator. The number 5 and addition with 1 actually is for mathematical satisfaction. We can see that the efficiency is inversely proportional to the ratio of the propagation delay and the transmission delay. If the propagation delay is overwhelming as compared to the transmission delay or the transmission time, the efficiency is going to be weak. It's going to be low. If the propagation delay somehow is 0, for example, it could be ignored on small LANs, and if the transmission time that a user gets is very large, say it increases to a very large number approaching infinity, then the efficiency is going to approach 100%. That is the kind of mathematical inferences we can draw from this basic equation. This two-dimensional plot establishes relationship of CSMACD and its variants with respect to pure and slotted Aloha. Here on the x-axis we see the total number of attempts in terms of packet time made. So if G is very large, say it is 9, it means 9 packet attempts are made. This surely is the recipe for collision. If the value of G is around 1 or approaching 1, we are talking about maximum efficiency. That is the intuitive conclusion we can draw from here. As we can see that CSMA is with a certain variance approaching 100% efficiency. For instance, with the usage of the notion of persistence and non-persistence, persistence implying this CSMA CD nodes which are using CSMA CD technology are relenting to the transmission and delaying their transmissions because they're sensing collisions. So their transmission would be delayed, but as we see on the y-axis, the throughput S is going to increase. This is of course at the cost of delay that is experienced. The non-persistent CSMA CD and 0.01 persistent CSMA are amongst the most efficient CSMA CD schemes, whereas persistent CSMA does not go very far and only gives us around 52% efficiency. But of course, it is a significant increase from 18% in Aloha and 37% in Slotted.